So crypto for Pentesters. This is kind of a story edition version of it. What I would recommend anyone who actually wants to learn crypto is to go buy the book that Christoph Parr has, or watch whatever method that you like learn in. If you're a reader versus a watcher, Intro to Cryptography by Christoph Parr is hands down the only one that like I could understand. Like he talks about it in super relatable terms. Even the book, like I had to buy the book to get the cert to pass the class. Like it was all part of my schooling at WGU. But I actually enjoyed the textbook. Like it's a really good thing, and that's thank you for coming to my TED Talk. The I don't get any money for it. It's just a good reference.
It sounds like he does,
All right.
though.
Yeah. So we're going to be talking about tools of the trade, CPU INI files, CPU INI files, SolarWinds, OpManager, and Axis. So if you don't know what nerd sniping is, you should definitely go check this out. Basically, I get nerd sniped a lot, and like people will say, "Hey, here's this base 64 encoded string, like go what does this do?" And then I'll go like, "Oh, I can figure this out." And 5 weeks later, I I finally figure it out, or like I hit my head. And I'm sure that there's plenty of people on the call or listening that can relate to this, but nerd sniping is definitely something I am vulnerable to. TLDR for this entire talk, if you want to leave right now, these two lines: crypto is easier than you think, and crypto still sucks.
Okay, bye.
So that's the entire talk.
Important.
I'm gonna like this
Know your
presentation.
vulnerabilities.
Also, I'm going to say at that perfect moment, Corey got up and went towards the door.
Can I just ask a question, rolling back
Sure.
a couple of slides? Will the link to the book or the textbook be at the end of the presentation? Because I'm going to want that.
It's not, but if you search for cryptography and Christoph Parr, it's the only book he wrote on it. So relatively simple.
Hey, Mobish, real quick, are you going to get into like the why this is important for pen testers?
A little bit, yeah.
Okay.
So these are the tools of the trade that I use. CyberChef is, for some reason, the multi-tool that everyone always wanted, that the GCHQ intelligence organization put out on GitHub. DNSpy, if you've never used it, it's awesome. It does the decryption, or not decryption, decoding of, or decompiling of C#, Hashcat, John the Ripper, cracking tools for hashing algorithms, which is not crypto. It's hashing. JD GUI is the decompiler for Java, and Pentagon Oracle attack. I use that particular attacker tool a bunch on like actual pen tests when I find a Pentagon Oracle vulnerability in them. CTF specific ones, I've never really used these tools anywhere other than CTFs, but they're also great crypto tools. FeatherDuster is really good at identifying the hashing algorithm or the crypto use. So if you don't know what kind of encryption or hashing or anything being used is, you can just put multiple iterations of it. So like, let's say that you have a column that has 17 things. It all says password, but you don't know what kind of password is or what kind of crypto it is. You can put all 17 of those in. FeatherDuster will try a bunch of different permutations and modifications of it, and it kind of tell you what it is. RSA tool, decryption and other attacks on RSA stuff. RSA CTF tool, about the same thing. QuipKip is actually pretty cool. It'll take almost any encoded text and tell you what kind of encoding it is, because it'll do it matching against English and other languages automatically. And so you just put it in here, hit solve, and it does it for you, which is kind of cool. So let's dive into CPU.ini file. What is CPU? It's essentially a from Quest. It's a super old tool. Used to be called EMW Prof. it's a migration tool from going from profiles from one box to another, or from nowadays from one box to in the cloud. I don't quite understand why someone wants to migrate their Outlook profile. I never figured that one out. Like your mailbox doesn't migrate. It's not migrating your mailbox. It's just your specific like profile settings specifically on that box, which
Like
again, I don't understand why anyone yeah, like your signature. But I think signatures synced already anyways. Like I don't understand what this thing migrates, but it's used all the time. So if a sysadmin out there knows why it's used, I'd love to know. So this is basically what the utility looks like on disk. Anytime I see that .config, I know it's C#. And so you run it and it shows up this, and this is how it looks. And lo and behold, hey, there's some kind of encryption, or not encryption, but credentials you can store. It has a CPU and INI file that stores in. So if you find the CPU and INI file, it's great. You got CPU.log, which we'll get back to later. So let's look at that credential input. You can prompt for credentials, use logger input, or store credentials, which is obviously the more secure method. If you store the credentials in the file, that's more secure, right? So there's different encryption modes, which is awesome. Restricted, which means that it's only for that user and specific host, which means that in Windows world, that means crypt protect and crypt unprotect. Those we're going to get into quite a bit, but that uses on host encryption built into Windows. Same with the current host restriction, but there's this other one, unrestricted, which is obviously the more secure method, right? Obviously. Well, it has you check a box that says, I have read the foregoing safety related messages, and I agree that I am responsible for the risks involved in any use of the unrestricted mode of encryption. It tells you that this is not safe and it's reversible.
It's always a good sign when they tell you that there's no safeties here. Good luck.
Well, actually,
go ahead and check that box. You
it
should definitely
actually
check the box.
Doesn't tell you that because it even references encryption in that. So is it actually using as encryption or reversible encryption, or is it just
the
not
saved
using
credentials
encryption at all?
may be vulnerable to reverse engineering?
Okay, so that's like in Active Directory. There's a checkbox you can say enable
Save
reverse
encrypted.
cryptography. Yeah, that's lovely.
So encryption can always be decrypted. It's all reversible. That's why it's called encryption, right?
True,
Because you can
as
decrypt
opposed to
it.
hashing, right?
Hashing, yeah. So no matter what it is, it's always reversible if it's encryption. So the default is to only use the current session. Like they did really good security on this. Quest is not like this is not a CVE for this. This is you have to go and check all the boxes to make it say don't do the good thing. So here it is when you find it on disk, CPU.ini file. If you are in an organization that has this tool or might have this tool, if you search your entire organization for files and you find a CPU.ini file, make sure it doesn't have those strings in them or say unrestricted, because that's bad. So let's start down this rabbit hole. Let's reverse engineer this encryption. All right, so I'm going to run strings on it very first thing to see what it says. Okay, so it says crypt, gen key, destroy key, import key. That kind of tells me that it's probably something to do with PKI, right? Then you on Linux, if you do an EL for encoding along, which is like UTF-LE, it will actually give you the UTF-16LE version of the strings, which is what Windows uses almost all the time. So you'll get actually better strings out of strings if you do the -EL. On Windows, it does both. For some reason, Linux, you have to specify it. We also see that admin TRG file or thing that we saw originally, the admin TRG here is there. So we know we're on the right track, that this tool, this client profile updating utility configuration.exe is what we should be looking at. So if you've never deobfuscated .NET, then one of the things that you can do with C# is you can obfuscate it with an obfuscator so that you can't just decompile it. So to deobfuscate it with when you're obfuscating it, you can use this thing called DE4 dot, which is one of the many deobfuscators out there. But when you run it, it says unknown obfuscator, right? But it literally says in the code what the obfuscator is. So because the obfuscator they used puts it in saying it was obfuscated by Confuser EX, which is a open source obfuscator. You can see on the left hand side all of these functions aren't actually readable. So I just go and look and see, okay, so Confuser EX version 1. How do I deobfuscate that? Oh, there's a version of DE4.net or DE4.-CEX that has the Confuser extension that allows it to deobfuscate it. Cool. Now I can see classes and modules and all this kind of stuff. So I start looking, search crypto, literally, find encrypted as a string. And there's the first one on the right-hand side. You can see encryption. Cool. Crypt protect, crypt unprotect. That's definitely the Windows one. That's the one where you're talking about like only allow credentials to be used on this one host or this one host and this one user. So I don't really have to care about this because this is not something that is not the target of this. We're looking for the unrestricted stuff. So that's the restricted one. Now let's look for the unrestricted one. Oh, cool. Crypt, encrypt, crypt, decrypt. So wait, there's no crypt decrypt, right? So there's only crypt encrypt. Crap. Well, this is probably not going to be doing the thing. We might be able to do stuff with it, but it's probably not going to be the right thing, right? So no decrypt. When you're talking about asymmetric encryption versus symmetric encryption, if you have the encryption, then you can do the decryption. If you have the decryption, you can do the encryption. But with asymmetric encryption, you have to find the decryption function to find the private key to do the thing. So we're kind of screwed here, but we're going to keep going anyways to see what this encryption looks like so that we can build it ourselves. So if we look in MSDN, we can find that the prov RSA AES equals 264 is the constant. That means that we're dealing with RSA and AES. We look at what kind it is, and it is RSA public-private key with 512 bits and all this fun stuff. And when you bring it up in when you bring it up in a debugger to find out where all this is used and executed in, I don't know. Like, I am not a reverse engineer. This is not something I do well, right? So I am like going, step into, step across, step all this stuff, and I'm like, no clue what I'm doing here.
Somehow you got a picture of Tim though.
No snap on snack.
Nice.
No,
so I asked online, and a bunch of people responded with Rohit Tab API Monitor, which is a fantastic tool. Basically, you can say, tell me all of the functions that say crypt and protect or crypt encrypt and all of this stuff, and you can follow executables by functions, and it'll tell you the pre-call value and the post-call value. So it'll even tell you what was in each one of those things. So if we follow along and we go to the crypt import key, we can see that crypt byte on the bottom left has PBD data, and that PBD data has the RSA1 thing. It looks like an RSA key to me, right? So we're pretty on par here. This is what I wanted to see. Unfortunately, RSA1 as a string inside of a key in Windows means it's the public key.
Right.
So I can't do anything with the public key. I can encrypt with the public key. I can't decrypt with the public key, which makes sense because I'm in the binary that does the encryption and it doesn't have the decryption, right? So time to decrypt passwords. Now, client profile updating utility configuration.exe was written in C#. It was super easy to look at. I just had to deconfuse it with Confuser EX. I had all that. It had the public key. Now, again, I'm not a reverse engineer. the other executable, which is client profile updating utility.exe, was written in C++. And it's probably the actual binary that pulls in the CPU.ini file and does the thing. So I tried running it because I don't know how to decompile a C executable except for like in IDA and stuff, or in Deidre, and still I'd be flailing around trying to figure this stupid thing out. So remember when I talked about logs? This thing logs everything. So I tried to execute it, it didn't work. And then these logs show up next to it, and I'm like, oh, cool. Interesting logs. Hey, look, it's saying that Outlook isn't there on my VM, and that's why it's not doing anything. Fantastic. I can either I can trick the binary into thinking Outlook is there, or me as a sysadmin, it's easier just to install freaking Outlook. So I install Outlook, and it's starting to do the thing, and you can see that it actually, in the log, for some reason it logs the whole configuration file, the CPU.ini. You can see the 3 stars for the password and the password TRG, so it is parsing it at some point. Cool. So run the thing. Hey, there's the RSA 2 key, because I just ran it with API Monitor again, and watching for crypt require context, crypt import key, crypt decrypt, and you can see in this slide you see the crypt decrypt. So a little bit bigger so everyone can see it, crypt decrypt, and the RSA key. Cool. I have that, and the resulting post call value is the credential that is in that file. Awesome. I can now go from binary with the simple tool API Rohit tab API Monitor to get the decrypted file. So on a pen test, drop CPU INI file, drop the binary because it's readily available on the Quest's website. I can Rohit tab do it and do it, but it's just a one-off, right? I'd have to load up this VM with Outlook and all these things every single time. That doesn't seem really fun, so I wanted to write it myself. I am not a C++ coder, so I decided to write this in C++ because that's what the original code was written in. So I got to stumble along figuring this thing out. And obviously, with any encryption, any at all, if you don't automatically output at the very beginning of the program, crypto is horrible. It doesn't work. So the first thing I did was with Rohit tab monitor, I watched exactly the calls, exactly the functions that every single thing in this binary was doing, which was not hard because it's just a few function things, right? Up to the point where it's decrypting it, right? So I only cared about the functions that were happening during the encryption and decryption. So all I did was copy this stuff out. So, open thread token, get token information, crypt require context, all that stuff. So I just copied that into my own C++ binary. So I get the crypt create hash. It's a SHA-512 hash. I copy this. This is actually pretty cool. Inside of the binary itself, inside of the binary itself, it has this string. And this string is the thing that it creates the SHA-512 hash out of. And it's just a bit string. And the interesting thing about this is that string is a GPO setting for Windows Outlook.
Woohoo.
Which is like it has nothing to do with its actual binary. It just happens to be a string that would like it's the key to the crypto, but it would look very normal in this binary because it deals with Outlook. So
Right.
they tried to hide the key to the crypto by making it look like a registry key.
Oh, okay.
Which is awesome. I thought it was pretty cool. So we perform the SHA-512 hash. We get the 8AE0 hash out of it. Cool. Next, we want to derive key. For those who don't know, like crypt derived key is actually really weird. So normally when you create a public-private key, you create these keys using random data, and it's never the same. It's very hard to create collisions even when you want to. Crypt derived key, is the exact opposite of that. You give it a password and it creates the public and private key out of it. And it creates the exact public and private key every time out of it, no matter what Windows system you're on. It's really weird. Like it seems like it's very
Across versions
against
of Windows?
I'm sorry?
Is that across versions of Windows?
Yes, across versions. You'll get the exact same public private key out of this no matter what version of Windows you're on. So it does that. It creates a crypt derived key from that original hash, which creates this private key that you then imports for the decrypt, and it decrypts this private key itself. So it creates the public. I'm sorry. Let me go back. It creates the key, the public private key, and then it decrypts this static string, which is an encrypted private key that it then pulls into memory. So one set of keys to decrypt the private key that's stored inside of the binary itself as a static string. So then it has the key, it destroys all things to clean up, and then it takes that private key that it pulled out by decryption, it then loads it up again into a new crypt acquire context. It imports the key that we just decrypted. There it is. And then finally, it takes the data that's in the CPU and INI file after two sets of keys that it's gone through, finally has the key to start decrypting. Well, inside of this thing, inside of the strings, I don't know what is important and what's not, because if you're talking about a password, it's not going to be this long. No matter what kind of encryption you use, it's not going to be this long. So you got to figure out how to parse it. And parsing it, it was relatively simple. Once you found where the header was, what the gen key is, and the ciphertext. So the final ciphertext is what you're looking at for the password, but it's actually using another key, PKI key, to do this decryption. So time to parse the text, it got all of that out. It imports that other public key. So it has the private key that it decrypted from itself. It has the public key that it decrypted from, or pulled in from the file. And finally, you get to decrypt the password. And there you go. So all of this, and it was all done just by looking through Rohit Tab's API monitor and following along, just one step at a time, trying to understand what this whole thing is. So I wrote the tool, it does the thing, it outputs the, and you get the password out of it. And the great thing about this is that you no longer have to have anything other than the CPU INI file, because it uses the same key every time, every place for all the things. So I do all the decryption inside the binary itself, and I really don't have to. So this to do here is remove all of the other encryption, just store the static key at the final level, and do the decryption.
All right, you lost me about halfway through. Can you start all that over again?
Sure.
I'm just kidding.
So crypto acquire context, SHA-512 derives the key, decrypts the key, gets the private key, puts it into another crypto acquire context, then imports the public key from the CPU and INI file, then does the decrypt.
So, but you said this is not a CVE though, so this is.
No, like they're doing excellent encryption. Like they're doing it really well. Like they're doing everything they can.
Yeah, unless someone chooses the really bad option.
Well, even the really bad option, they're doing a really good job at encrypting as much as they can. They're using like 3 public-private key pairs just to get down to the password.
Okay.
Like in order to make a portable executable, you have to have the crypto somewhere, right?
Right.
So there's not much they can do more than what they've done. So I'm just saying, like, Quest is doing an amazing job at this.
Okay.
It's not a fault of
What would
theirs.
be the defense against something like that?
Don't leave the CPU INI file anywhere lying around. Pick the restricted version and not the stored credential version, like the prompt for credentials thing. Like,
So
you don't have to
get rid of that option and just not make that option.
I mean, like, this is a migration tool. At no point, I don't understand why anyone would want to automate this other than sending it to someone so they could double click it themselves and not have to worry about it, right? Like, if I'm in tech support and I want them to execute this person to execute something, I want to have everything built into it so that they don't have to worry about anything, right?
Yeah,
It's prompting for.
I could see, if you have 3,000 people that you're trying to migrate in a reasonable amount of time from one system to another, that might be more important.
Yeah, I don't know, man. Like prompting employees for credentials is still something that I'm willing to do.
Fair.
Yeah, that's pretty
So-
standard actually. I mean, it's tough for third-party software, like Quest to integrate with, your on-premise Active Directory or whatever you have. So it's
Yeah.
easier just to prompt them and put
Should be, yeah.
Windows Forms or something like that, whatever they're using to, validate those credentials. So unfortunately, prompts are probably, or local accounts, software local, for authentication. So you're going to end up worse for wear if you try to do anything different.
Yeah. The other thing is that this prompts for two sets of credentials: the account that it's migrating from and the account that it's migrating to, and so that might confuse people too. So all of the code is publicly available. It also compiles itself over on GitHub, and the QR code is absolutely safe. I swear.
Yeah, just like the link you posted in your social media.
No
Yeah.
trust.
That's okay. I've
SolarWinds.
got a great Android 3D barcode decrypter that does nothing bad.
Nice. Yeah, I noticed like a year and a half ago or something that iPhone and Android now on the standard picture app does QR reading and auto opens things, and it's like, why? Anyways,
Well,
So-
actually today I had to scan a menu and it didn't auto open it. It showed a little pop up with a Chrome icon. So I had
Yeah.
to click on it, but it went to some gobbledygook menu thing. It didn't say menu.com or something like that.
Yeah.
So yeah, might as well have been malware.
all right. Next up is SolarWinds. I know none of you have ever heard of this before. It's a cool tool that's out there.
Could you explain to me what SolarWinds is and does? I'm kidding.
It's a software
So-
conglomerate.
Yeah. So SolarWinds used to have admin blank as the password. They actually added so blank as in like nothing entered, not
Oh,
BLANK. So they made it so that when you logged in for the first time, it forces you to change it, which is awesome. It stores all of these credentials. So for those who don't know what doesn't know what SolarWinds is, it stores all kinds of credentials in it. And for some reason, I've even seen Twitter credentials inside of SolarWinds databases. I don't know why. Maybe there's a way to update things, like get status updates from Twitter or something. I don't know, but yeah. So inside of there, inside of the database for SolarWinds, there's two sets of. There's a bunch of different places where credentials are stored, but particularly credential and credential property. And you'll see inside of here that it's encrypted. It even tells you it's encrypted by that nice little checkbox. Because that's how you know when something's encrypted. Is it has a checkbox next to it.
I thought
So
that was the
let's-
padlock.
So let's go back into DN Spy. SolarWinds onion.security.dll is C#. We can see those config files again, which is awesome. The crazy thing about SolarWinds encryption, though, is it uses they actually do a really good job at things. Again, they do some really cool things. The only bad thing is that they still do, unfortunately, is they uppercase every user password, which is insane to me. Like if I log in with, uppercase PASSWRD lowercase 1 or lowercase WRD 1, it's all going to be uppercase. And so like no matter, you can log in however you want, but it's always going to be uppercase. Even in the latest edition, it uppercases everything, which is crazy. But it does encryption based on a RSA encryption with a certificate that's generated on install, so it's not static across installs. There's also this default file that's now a newer method that they've added. I'll talk about that more. They do crypt, protect, unprotect. They use like every crypto that is available to them, which is good, except for this old encryption that we're going to talk about in a second.
But
So yeah. So handy database manager and application. If you get on a SolarWinds box, this thing is definitely there. It does all the crypto for you. So if you get server details on it, it will auto log in to the database. So you get all the output from it. You can export stuff. It also tells you what the password is that it connected with, which is great, and it does the crypto for you. So it's built in on the box. I mean, you have to have GUI access to the box to get to this point, but you could log into the database automatically, which is fantastic. So let's look at where that database connection is happening into SW net perfmon. I'm using process monitor on my own VM to find that. And so inside of here, oh, cool, another text file with encrypted text. Fantastic. No idea what this does. So we'll get back to that in a second. But it uses crypt, protect, crypt, unprotect on that one. For the cert, it also has certificate-based encryption, and this cert, for some reason, is exportable, which a certificate should not ever be.
Oh god.
But it's exportable, and exportable by pretty much any user, which sucks. So if someone gets access to your SolarWinds box, they can do all the decryption they want forever. So when you start looking at DNSpy and all these tools, you can do the same thing. Search for encrypt, decrypt. So if you're a programmer, stop calling it crypt decrypt because that's what I'm looking for.
Like dog or cat.
Yeah. So inside of the old password hashing, this is the new one. So in the new password hashing, you can see that they use SHA-512. None of this is obfuscated, which is great. Unlike the CPU INI file, all of this is decompilable very easily. And the salt, it tells you what the salt is. It gets you, like, all of this is built into it, so it's super easy to find. And it's just SHA-512. It does do, so it does SHA-512, then it does PBDKF12 or PD whatever, that PBDKF thing. It does it like 1,000 times. It then does encryption on top of that. I don't actually show it, damn it. So it does a really good job at doing encryption or hashing on the passwords that are stored. The only problem is they're all uppercase. Like,
So tell me,
they're doing awesome hashing, but uppercasing all the passwords.
But so is that because it makes it, that's one less character type you have to?
That's 26 characters you don't have to worry about anymore.
Okay,
which is a massive amount.
But how do you? But you only know that because you have access to the database.
I know that because I've decompiled SolarWinds. Like if I wanted to guess a password on SolarWinds, I would always use the uppercase version, and there's no
Okay, so yeah, theoretically you could download a trial version of the software, install it, decompile it, and then figure that out, and then go.
Absolutely.
Okay, I got you.
Or go to my blog post about it where I talk about it, or watch this video.
So did they take no note from NTLM about that
LAN hashing? Yeah, no. So anyways, they do really good. They do really good hashing, but they do horrible uppercasing. They also do AES encryption, decrypt short, decrypt XML. I'll show some of that later. One of the interesting things is decrypt XML is built into Windows. You can encrypt XML and decrypt XML, and you just give it text, and it creates an entire XML document with all of the crypto built into it. So, like, you can say encrypt the string password, and it will encrypt that text and then give you XML output with public private key and all this stuff built into it so that you can take it onto another box and decrypt it, which is insane to me. So decrypt short, decrypt AES, we'll get into those. The one interesting thing is there's also an encryption, a decrypt password that I found that has a string that says, "Do not use this decrypt algorithm. It's not FIPS compliant. Use hash password instead." So they're literally telling you, don't use this, but they still use it. Like, I don't know who they're talking to, but it's not their programmers, because like they're still using it. And they typoed the encrypt. Like, it's just decrypt. I don't know who wrote this.
There's a team of programmers within SolarWinds that is crying right now because
1,000 of them apparently.
they wrote that code and like they wanted to block it out and were told no, and then they put a comment, "Please don't use this," and that's
still
as far
people
as it
use
got.
it. Yep. So inside of here, it's actually just long division. They take the password and do long division on it. That's it. So here's the math that I told you about. So that's the password in the top right. The passwords as stored in the database. You'll see a 11 dash whatever. So all you do is take after the 11, you put it all into a single string or a single number. You then divide it by 11. You take the resulting of that and you divide it by 1, 2, 4, 4, 3, 5, whatever. That's actually built into the shell or into the code. That's a static string. And then it gives you the hex or the digits for hex out of that. So that's the password that this decrypts to is 0pqu.eq whatever. And that's it. Like, you could do this math on a calculator. Well, a big calculator. You can do this math on CyberChef. Like, it's super simple, and you can decrypt the password anywhere. You don't have to have access to anything other than the database to pull these out. So there's an example of an uppercase password that I decrypted because all of them are uppercase for some stupid reason. So the default.dat file is another newer version of things. I don't know when it came out. They started doing encryption this way for AES. It's 2008, 2019-ish. So looking at it, you can see that there's a new encryption thing that says -ENC-2, and everything after that's encrypted, or base64 at least. So
check mark.
Yep, and you see the check mark. So I actually posted a request to Hashcat to add the algorithm for the old uppercase passwords that had the salt of the username. And now I actually have a new request into Hashcat for the newer version of these passwords, and they're all uppercase as well. So all of that crypto for SolarWinds, super easy. They did try very hard, but Solarflare is my tool to not only pull out all of the details for it. You get the passwords out. It does all the encryption, decryption for you. It connects to the database and pulls everything out of there. It does all of the things automatically for you. But the nice thing is it's all open source and in C#. So if you want to look at how all of the encryption and decryption works, it's there. And I did a good job at commenting what does what. All right, so ManageEngine. Another thing a lot like SolarWinds. It has default credentials. It even tells you on the web interface what the default credentials are. The username and password are admin. It even fills it out for you.
Everyone's favorite router has admin.
Yeah. So OpManager, on the other hand, is Java, not C#, but Java is decompilable as well. The interesting thing about this is that inside of wrapper.conf, which is in the install of this thing, it actually has lines that tell you how to enable the Java debugger. And I had never used Java debugger before. It's really fantastic. So you can take compiled code and have the Java debugger run, and it opens up on port 8787 by default. You can configure it, as you can see here. It's configured for 8787 for some reason, but that's also the default port. And So JDWP is the port that you can talk to it over. If you find 8787, you might have a application that's already running the debugger. So all you do is tell it to connect to it. So like outside of OpManager, thinking just Java-based applications, if you find JDWP listening, you can connect to it with a debugger and debug, and you can even run code. Like I was able to tell it to run code, right? Run stuff, like whatever Java flags that I wanted. So like java.runtime, run calc.exe. It did it, right?
But you had to put in the super complicated password.
What password?
Admin.
No, I don't have to add any password to this. The JDWP is open to anyone who wants to connect to it.
Nice.
I think there is a way to make it require auth, but I didn't see it easily set upable. I don't know. Anyways, so OpManager is gigantic. And so like I don't have time to decompile all of these jar files. So
security through obscurity.
Right. So I started looking at the database instead to find things, and it has this encrypted password in it, which sucks. So this is the VI credential that I added to my own thing. I called it super user, but this password is weird. I don't know what it is, but it does look like it has some kind of header. If I add a bunch of passwords in there, the same string keeps on popping up at the very beginning of things. And so I know that it's encrypted. It's not fully encrypted because it has some kind of header. And so I'm looking at this thing. I'm going, okay, what is this thing? Come to find out, looking through a bunch of the code, it uses Postgres's built-in PGP symmetric key encryption and decryption, and it has a default password of Mickey for some reason. And so you can then just tell PGP to decrypt the password itself, right? So I just on the database told it, say, hey, give me the decrypted password. Unfortunately, it gives me a base 64 string in this case. A lot of other cases it just decrypts it, but in this case for the password, it just gives me base 64 thing. So I start looking for encrypt decrypt in the jar files. If you've never used BearGrep, it is hands down my favorite tool on Windows ever. I still use it to this day. I love BearGrep. It's basically a grep tool, but it can do in file text. It can do shares. It can do regular expressions. It can do all the things grep can do, but it's all GUI based and it's fantastic.
Nice.
If you've never used JDGUI, JDGUI does the decompiling. So I opened up JDGUI. I opened up OpManager server classes because that's what was listed in here. And I looked, okay, there is the set password, decrypt password. I am on the right track, hopefully, because decrypt password is where I want to be. Look at decrypt password. In JDGUI, you can actually click on it and it'll open up the class where that is, which is fantastic. You just follow down the tree. So decrypt password. Okay. It creates an object called OpManager password decoder. Fantastic. Let's click on that. Okay, this is getting more interesting. It has this DES thing. So it actually uses DES, not triple DES, DES encryption for its passwords. So this is installed as of today, right? Like this is how it does it right now. So it uses DES encryption for all of its password, and it uses a static key for all of its DES encryption. So let's break this down again. Let's do it on CyberChef of all places. So we go get the OPM connector thing, which decrypts into this long string, which is the same on every single install, but it only uses 8 bytes of that. So even if they manage to randomize it at the end of it, it's still going to use only the first 8 bytes. And then they use ECB encryption or mode instead of ECP for some reason. I had that, and you get the password out of it. That's it. So if you get them out of the database, you have all the creds. And the great thing is that OpManager has all of OpManager actually has a SQL query tool built into the enterprise version. So if you can log into OpManager into the web interface, you can query the database and do the PGP decryption without ever being on disk right from the web interface. And then you get all the credentials down, and then you go to CyberChef and do the decryption.
I just hope you're unemployed because I don't need you anywhere near my environment.
So Manage to Decrypt was posted today. I posted all of the stuff on how to do that. It also shows you how to decrypt the database password stored on disk. And that's already on GitHub as well.
Wait, why do you want him unemployed? It's better if he's employed and distracted. If he's unemployed, he's got nothing to do but come and.
He's got more time in his hands.
No, I
Right.
need him unemployed so he's not going and hacking away on my environment or people like my environment.
He's gonna do this regardless, man. It's a no-win
Yeah.
situation.
I know. I'm grasping at straws here. I'm crying on the inside.
Hey,
So
Jose,
anyone ever heard of Access before?
Like
I want to.
AC
Why are you like this? Why? Why are you like this?
the access powers.
No. So Access, if you didn't know, we were talking about supply chain earlier. Access controls supply chain software.
Oh god.
Great.
It is
I
it is
don't
the
wanna-
thing.
No,
that
turn it
handles
off. Stop.
So as we progress down into this presentation, you'll notice that we're getting less and less secure, right? Less and less.
That's not a
Awesome.
Wait,
progression. That's
SolarWinds
a
is at the top?
degression.
So no, CPUI was the top because it had all those warnings and like triple PKI encryption.
It's getting
SolarWinds is the next one
worse.
down.
Oh
Yep.
no.
I mean, we got to DES. What do you think we're at now?
Triple
So
dead?
inside of the code for access.common.dll, it has encrypt and decrypt. If you can notice, it says it for some reason this code comes with a PDB file. So they deploy with all of the debugging inside the file. And so you get all of the comments for all of the code.
Oh god.
And so if you look, here's the crypt decrypt. Here's even more crypt decrypt. And if you look at encrypt string, guess what it's doing? It's doing AES encryption with a default key and default IV. If you look at the bottom, you'll see what those key and IV is. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
I can hear
Repeated
a
until
developer right now saying, "Yeah, we're using encryption."
I see the developer saying, we're going to change this before it rolls to production, and then they get fired and it never gets changed.
So I decided that to try this out, I pulled up my handy dandy Visual Studio. I literally copied the code from one place to another and ran it because I didn't need to run all of Access. Copied the code directly out because I didn't want to figure out all the crypto. I added the key, the IV, and the string I wanted to decrypt. And guess what? There's password. So I did the entire thing in CyberChef. So without having to write my own tool for it, I'll just use CyberChef for the entire thing. So
Is this the essential of like a Caesar cipher in like the 20th century?
essentially. So one of the interesting things about this particular is that fork option. In CyberChef, you have the ability to say, do the same thing for every line instead of, treat the entire thing as one line. So I was able to pull out the entire database of encrypted passwords. So all 70, 80, 90, 100, passwords, throw them all into CyberChef, use the base64 decode, use the AES decrypt in CBC format. I used the key 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the output is, you can see a bunch of passwords. And that's, CyberChef is my tool that I'll be releasing for this. And stay tuned. I'm not done with this app. There's a lot more in Access. There's WCF stuff. There's all kinds of attack vectors here. I'm not done with looking through this code. and that's it.
To be continued.
It just strikes me as odd because most of them seem to do fairly well with layering encryption and trying to do things, but then taking a shortcut somewhere along the way that just shoots them in the foot.
Absolutely.
And that just
Okay, well, here's what I run into a lot is it's behind a firewall, it's behind a bunch of, it's essentially like someone said earlier, obfuscation. It's behind something, but I have to explain to people, it's like, do you want to be a gobstopper or do you want to be an M&M, right? You got a hard shell on the outside. Do you want that gooey center or do you want to be that hardened center? Because people always get in, and it's not even just people getting in. It's a rogue developer. It's essentially the developers, and the developers shouldn't know everybody's passwords, but clearly they could just go decrypt it all.
Well, okay. So to be fair, like the database has to decrypt things. Like it can hash things when it can do the comparison. But if it has to use things like OpManager and SolarWinds, where it has to use that password to do something, it has to decrypt it at some point.
Right.
So like there's very little you can do as a developer if someone has access to the box itself to stave away someone decrypting it at some point. They can either do it in memory or like decompiling the application. Like you can make it super hard. You can make it a C++ binary, or that has to rely on a bunch of different things. Like there's ways to make it hard, but ultimately you have to decrypt the password to use it, right? If you're going to use it.
Right. I mean, yeah, I get that, but I mean, it's still like a junior dev comes in that probably shouldn't have the password. He could figure this out just looking at the code, or
we have that competition between what's become kind of DevOps. That idea of we have a large number of systems or things that we have to manage, and we're going to use an automation tool to do it versus we're going to do it by ourselves. But that means updating and doing firmware revisions takes 3 months, and that goes beyond, then you run into problems with not being able to patch in time when something critical happens because you have this infrastructure that doesn't allow it.
So the right way to do password storage, if SolarWinds and an OpManager, if they wanted to do password storage, they should do it in a way that is just in time. So, so I don't know how many of you you've used Vault before, but HashiCorp has this really cool tool called Vault. You can call API calls to pull a password out in real time. And so the great thing about this is that it can also change it. So let's say that you have SolarWinds and somehow you got it to work with Vault. All of the execution of it running to query servers and get updates and stuff, it could do that by calling Vault, give me the password. It would get the password from Vault using some certificate-based authentication that you could lock down to a specific IP. So you'd have only that box being able to access it ever, and then after it was done using it, it would check it back in and the password would change instantly. So like that way an attacker would have to have a password that was only good for a short amount of time, because SolarWinds is going to use that password a lot, right? So even if I can do all the decryption, I'm not going to know what the password is because it's going to change it 5 minutes later.
Yeah, I've seen that on like privilege, what do they call them? PAM, privileged access management systems. Like you don't own the password, you don't own the authentication. You're just a guest of it. So all that rotation is done for you without your knowledge. So, but
yeah, and Vault actually has an AD integration tool too that I highly recommend people use. Like it's fantastic.